In this video, we're going to look at the required practical which investigates the equation F is equal to m times a. That's force is equal to mass times acceleration. This is how to set up the experiment, so it's the first video on this. Now, what the aim of the experiment is to show that, that this equation is correct. Force is equal to mass times acceleration. We're going to do that by changing the force on a trolley, taking some measurements to allow us to calculate the acceleration of the trolley. We're then going to plot a graph of force against acceleration, and if we keep the mass of our system the same, what we should get is a nice straight line showing that force is proportional to acceleration. So, your setup. What we have done, what I'm going to do is just show you quickly what the setup is. I've got one light gate that is attached to my data logger, and I've got my data logger for timing at A. I've got a pulley at the end of the table, and my trolley has got a bit of string that goes around the pulley, and we're going to attach some masses to the end of it. Now these masses are going to fall down to the floor. I don't want them hitting the floor and getting damaged, so I've got a tray with a towel on it to catch the masses. The other thing on my trolley is an interrupt card. Okay, so this is the card that's going to block the light gate. So I'm going to show you how we're going to take some results using this equipment. First thing you need to do is you need to make a copy of the results table. So here I've got a results table, mass in the first column, that's the mass that we're going to hang off the edge of the string. That's going to create a force that's going to pull the trolley along. We're going to record our results for time. I've got space for trial 1 and trial 2. You might want to do 3 trials if you've got time, and I'm going to work out the average result of those. I'm going to calculate the speed and the acceleration that I'll show you how to do in the second video. Now, really important, you need to record 2 different things. You need to record the length of your interrupt card, and you also need to know the distance that the trolley travels. So, first thing, your interrupt card, you can see how I've stuck an interrupt card onto the trolley, and I've put sellotape on each side to make sure it stays there. And can you see I've measured across 13.3 centimetres. I'm going to put that in metres because we usually want to use metres in calculations in physics. And I'm going to write that in my book underneath my results table. So it's there, I've got it there, and I can use it to interpret some results. Now I've got to set up the experiment so it works properly. What I'm going to do, I'm going to think about where I'm going to set the trolley off from on each of the experiments, and it's going to start at the same place each time, but it's really important that you work out where the best place for it to start would be. So what we're going to do is you're going to pull back on the trolley. As you pull back on the trolley, that's obviously going to raise up the mass here, and I want you to pull back the trolley until the mass is, you see that knot there, that knot's nearly on the pulley. It's not quite, but it's nearly on the pulley. And I want you to have a look at where your trolley is at that stage, and I want you to draw a start line. Okay, so I've got my start line there. Then move your trolley along. We're going to find out where the finish line is. Well, I want you to get the finish line just before that mass hits the floor. So can you see I've also written finish there, so I know where my start and my finish is. Now what I'm going to have to do as well is make sure that this light gate picks up the time just as it gets to the finish line. Okay, so I've got that at the finish line, I'm moving my light gate so it's just gone through when it gets to the finish line, it's not slowed down at all. Okay, and that's my setup. Now what I will need to record is the distance in between my finish line and my start line, so I can use my meter ruler to do that, and I found out that it was 63.2 centimetres. Okay, so 63.2 centimetres or 0.362 metres. That's what I've got for those 2 things. So before you record any results, make sure those are recorded, okay? And yours might be slightly different. Now, couple of things about this experiment. We've got to keep the mass of the system the same. So we're going to change the mass that we put on the end of the string there, but we can't just keep on adding extra masses because that would change the mass of the system. So you can see, to start with, I've got 5 masses, 500 grams on my trolley, and I've also got the 100 grams being attached to the end. So what I'm going to do is I'm going to do 2 lots of experiments with this, and then I'm going to move one of those 100 grams to be on the end of the string there. So I've always got 600 grams and the mass of the trolley on the system. So when I want to take a reading, all I need to do is release this from the start line. I've got to make sure it's lined up so that it will go through the light gate, and as it goes through the light gate, it's going to block the light gate. I might need to do a couple of different trials and move the light gate so that it's going to definitely go through that. Now, I don't want the trolley to come along to the end and fall off the end of the table. So I'm going to have one of my group is going to be in charge of making sure that the trolley stops when it comes to the end of the table, and I'm going to get some results. Okay, so for 2 lots of results. Now just be aware that when you get a result on this, it is in milliseconds. You therefore need to divide by 1,000 to get that in seconds. So that would be 0.52960 seconds. Okay, so 2 sets of results with 100 grams. Then, as I said, just pull one of these off and put it on the end, so we've got 200 grams pulling the trolley along.